We're going to solve some logarithmic equations. So I have 8 log equations that I want to solve for x in each one of the problems. And then I have 3 more problems that have exponents and that are exponential equations that I want to solve that are a little more challenging than what we've seen before. So here I have log base 5 of x is equal to 3. How can we solve this problem? Well, what you're going to do is you're actually going to rewrite this in the exponential form. So remember the definition of a log. A log is an exponent. So this is the same thing as saying 5 cubed is equal to x. So what is 5 cubed? That's 125. So then log base 5 of 125 is equal to 3. So we know that x is equal to 125. That's the number we're plugging in right here. Here's the second problem. I have log base 3 of 3x minus 2 is equal to 2. Okay, I'm going to do the same thing I did before. I'm going to switch this to an exponential statement. So this says the base 3 squared is equal to 3x minus 2. Well, from there I can see that 9 is equal to 3x minus 2. Move the 2 to the other side, I get 11 is equal to 3x. So x is equal to 11 over 3. You can double check this if you want by plugging it into here. So if you put 11 over 3 into here, you'll get 3 times that's 11 minus 2, that'll be 9, and 3 squared is 9. Here's the next problem. Log base x of 1 over 8 is equal to 3. Again, I'm going to change this to an exponential statement. This says x to the power 3 is equal to 1 over 8. I don't think we've seen anything like this before, but there is a rule that says if a to the power m is equal to b to the power m, then a is equal to b. So is there some way to write this as a number to the power 3? And the answer is yes. Notice that 8 is 2 times 2 times 2. So 1 over 8 is 1/2 times 1/2 times 1/2. So x cubed is 1/2 cubed. So then x is equal to 1/2. And again, you can double check this. 1/2 to the power 3 is 1 over 8. Let's try this one. The natural log of e raised to the negative 2x is equal to 8. What I would do first is I would rewrite this ln as log base e of e to the negative 2x. I'm going to put this in parentheses here, is equal to 8. Now we're going to convert this to an exponential statement. So this says e to the power 8 is equal to e to the negative 2x. Now here we have the same base, so remember that if you have a to the m is equal to a to the n, and that tells you m is equal to n. So this 8 is equal to negative 2x, so x is equal to negative 4. Plug that in. Negative 4 times negative 2 is an 8, so you have e to the 8 here, and the base is e, so e to the 8 is e to the 8. All right, we have log base 5 of 625 is x. This problem I think is similar to the first problem. So pause the video, try the problem, and see if you can get the right answer. Okay, I'm going to switch to an exponential statement. So 5 to the x is equal to 625. Is there a way to write 625 as powers of 5? So let's see, 625, I'm going to divide it by 5. Let's see, I got to pull out a calculator. So 625 divided by 5, that's 125. So let's write that down. And I know, because I've done this a lot, this is 5 times 25, which is 5, 5, 5, and then 5. So in other words, 5 to the 4th is 625. So we can say 5 to the power x is equal to 5 to the fourth, and now we have x is equal to 4. Okay, let's try this one. We have log base 6 of 36 is 5x plus 3. You might get a little confused with this one because we have two things on this side. Maybe put parentheses around these two things, because what this is saying is 6 to the whole expression, 5x plus 3, is equal to 36. Now where can I go from there? Well, I can rewrite 36 as, well, this is 6 times 6, so 6 squared, excuse me. So since we have the same base, we can set 5x plus 3 equal to 2. Subtract 3 from both sides. We get x is negative 1/5. Plug it in. If you plug in negative 1/5 here, this will become negative 1 plus 3, so you'll get 2 here. And 6 squared is 36. Here's the next problem. Log base 3 of 3x is equal to negative 1. Okay, so this is 3 raised to the power negative 1 is equal to 3 to the x. Well then, negative 1 is equal to x because the base is the same here. So that's the solution. And one more. We have log base 5 of x squared plus x plus 4 is 2. Okay, be careful with this one. So this is 5 squared is equal to x squared plus x plus 4. So we get 25 is x squared plus x plus 4. How do we solve this one? Well, this is a quadratic, so move everything to one side. You get that x squared plus x. Subtract 24, I think you get minus 21 is 0. Is this factorable? Just make sure I didn't do anything wrong. I think everything looks good. So 21 is 7 times 3, right? So we want two numbers to add to give us 1. I don't think you can factor it, so maybe we should use a quadratic formula. So x is equal to, well here this is a, b, and c. Remember the quadratic formula. If you have, let me write it here. Okay, the quadratic formula says if you have 0 is equal to ax squared plus bx plus c, then x is equal to the opposite of b plus minus root b squared minus 4ac, all under that root, divided by 2a. So now I'm going to plug in these letters. Here a is 1, b is 1. So 1, 1. A is 1. C is negative 21. This is 1, so I'm just going to erase that. And we get negative 1 plus minus square root. We have 1 plus, that is 84, is that right? 84. So I think this is 85 over 2. So you get two answers, negative 1 plus square root 85 over 2 and negative 1 minus square root 85 over 2. So if you plug those into here, you should have something that simplifies, and that 5 squared will give you that, whatever that is, simplified. So double check that and make sure I didn't make any mistakes, and make sure that you do get a true expression. Okay, so that's the last problem of those. Now I want to solve these exponential equations. If you remember back in a video, I asked, how do we solve something like 5 cubed is equal to 7? Because we know how to solve something, 5 to the x is equal to 7. Because we know how to solve something like 5 to the x is 125. We could write this as 5 cubed, but there's no way to write 7 in terms of 5 or 5 in terms of 7. So how would you solve something like that? And here is how we're going to do it. We're going to use logs. Now, these logs that we're going to use are logs that the calculator can handle, because you're not going to be able to do this without using a calculator to solve something like this. So the first ones we're going to look at involve the natural log and the common log. So we have a base e or a base 10. Here, because I have base e, we're going to switch this expression to a logarithm. So let's write it as a log. This is log base e of 13 is equal to negative 2x plus 1. Remember how you switch. Put a log, the base goes in the basement down here. What's here is the exponent, and what goes here is this negative 2x plus 1. I mentioned in another video how I think about it is I switch these two and put a log in the front. Now this log is the same thing as the natural log, ln of 13 is equal to negative 2x plus 1. I'm going to solve for x, so I'm going to move the 1 to the other side. I get ln of 13 minus 1 is negative 2x, and then I'm going to divide everything by negative 2. So I get ln of 13 minus 1 over negative 2, and that's going to be my answer. So I'm going to put this in a calculator, and I'm going to show you what I get in just a second. Okay, so let's switch over to my graphing calculator. Also, give me just a second to jot this down. So we have ln of 13 minus 1 over negative 2. So that's what I'm going to put in the calculator. Okay, let's share the screen. So I'm going to type in the numerator, I have ln of 13 minus 1 divided by negative 2. And I'm going to round this number. This is about negative 0.78, let's say 2. Okay, so we wrote this down. Let's go back. So x is about negative 0.782. And what I'm going to do is I'm going to double check this. So I'm going to write this equation down on a piece of paper, and I'm going to put this in my calculator. And what I'm going to do is I'm going to put this number in for x and see what happens. So let's go back to our calculator. Okay, so we have e raised to, here I have negative 2. I'm going to put that number, and I'm going to round this number. So it's not going to be the exact number, it's going to be rounded, so I might get a little bit of an error. I have 7, 8, 2, 4, 7. I'm going to put as many numbers as I see. And then I'm going to add 1 to that, and look what I got. I got 13. So it turns out if I did put that number in here, this equals 13, and that was the number I was looking for. Okay, so let's go back, and let's try another one. Okay, here I have 8 times 10 to the 2x minus 7 is equal to 3. So whenever you want to put something in a log, here I'm going to use the common log. What you want to do is you want to isolate this exponential. So let's divide everything by 8. So we'll get 10 to the 2x minus 7 is equal to 3 over 8. And now because I did that, I can switch to a log. I'm going to say log base 10. Remember, switch these two and put a log in the front. So I have a 3 over 8 is equal to 2x minus 7. And now my calculator can handle this. Remember that the button to use for the common log is just that button that says log. And we're going to solve for x. So we're going to move the 7 to the other side and divide by 2. So I get x is equal to log of 3 over 8 plus 7 divided by 2. Okay, I'm going to write this down on a sheet of paper. And then I'm going to put this in the calculator to see what we get. Okay, so let's erase this stuff. And we had log. So remember, just if you type in log, the computer knows that that is the common log, so the base is 10. Also going to put a division sign up here. And I'm going to put +7, and then in the bottom I'm going to put 2. And you can see that I get about 3.287. I'm going to write that down. And I'm going to switch over and write that on my paper. This is about 3.287. So again, you can double check by plugging that into here, multiplying this left-hand side and seeing if you get 3. Now we did some advanced problems. I just want to make sure that you understand what's happening here. So I'm going to do a really easy problem just to double check. So let's say I have 10 to the x is equal to 7. 10 to what power is 7? Well, what we're doing is we're switching to an exponent like this. We're taking the exponent, switching it to a log. So if we switch, this is log base 10 of 7 is x, and then we put this in the calculator. And because this is the common log, all we have to type in the calculator is log 7. That will give us this x. So let's do that. If I hit log 7, I get this 0.845. And notice what happens when I raise 10 to this number. So 10 up to the 0.847, 845, 098, 04, 0014. Look, I got 7. So we're finding that exponent. And because we can't do that by hand, the calculator can do it for us. And so we're using the calculator as a tool to get to that answer. Okay, now let me go back. Now the last thing I want to talk about in this video is something like this. Notice that each one of the problems I gave you, and I'll scroll up so you can see them, I did a base 10. I did a base 10 here. And the very first problem, I did a base E. All of the things that I've shown you will work for base 10 or base E, because that's something your calculator can handle. We have this ln and log, but what if you have a different type of base? So like this last problem I have. We're going to study this more in another video, but I can tell you what you need to do for this. So it's the same thing. We would do log base 5 of 4, that will give me x. So I would need to plug this in the calculator, and if I can plug it in the calculator, then I'll get the right answer. So in my calculator, I can do that in this desmos.com. So let me type that in. Okay, I'm going to look at it real quick. So our problem was log base 5. So I'm able to put in the base that 5, and I got 0.8613. And notice that if I put, wait just a second, because the problem was 5 to what power is equal to 4. So if you do 5 to the 0.861353116147, you can see we get 4. So my calculator is able to handle this, but some calculators can't. The only logs that you can give is the natural log, so you can type in ln of something, and you can type in log. For example, if we look at the TI-83, you know where the log button is and where the ln button, but how do you get something with log base 5 or log base anything? All you need to do, so let me switch back over right here, is when you have something like this, and we're going to prove this later, this is the same thing as log base 4 divided by log base 5. So you just need to type log base 4, close the parentheses in the 4, and then divide by log base 5. Or you could do ln of 4 divided by ln of 5. That will give you the right answer. So you can switch to the common log or the natural log, and you'll be able to get this answer. So it's log of this number here divided by log of what's in the basement here. So let me switch over just to prove it to you. So we said this was the answer. So if we do log of 4, so make sure, let me do it like this, division sign. So in the top, log of 4 divided by log of 5. I got the same thing. Oops. And if I do it here, ln of 4 divided by ln of 5, I get the same thing. So that's a way, if your calculator cannot handle something like this, to get around it.